Hello dear student, welcome to another lecture in quantum mechanics. This is my fourth lecture in quantum mechanics. So far we have learned about failures of classical mechanics which led to the evolution of quantum mechanics. We have learned about blackbody radiation spectrum and the classical and quantum mechanical attempts which were made to explain the blackbody radiation spectrum. We have also learned about wave function and its physical significance, and also how the wave function tells us about the presence of a system in space. In this video, we will learn about the Schrodinger wave equation, the time-dependent Schrodinger equation, and also its derivation. Now, what is a Schrodinger wave equation? We have learned about wave function in the last video. In the last video, we said wave function is the wave of a matter or a matter wave which contain every information about that system. The Schrodinger wave equation actually tells us how the wave is going to be in the next moment, or it predicts the path or the future of that system. The Schrodinger equation is a linear partial differential equation that governs the wave function of a quantum mechanical system. It was named after Erwin Schrodinger, who postulated this equation in 1925. This equation was published in 1926 and he got a Nobel Prize in 1933 for a work related to this equation. The Schrodinger wave equation plays a role of Newton's laws in conservation of energy as in classical mechanics. Just like in classical mechanics, the Newton's laws tells us how the equation or how the system is going to evolve in future. The Schrodinger wave equation tells how the quantum system is going to evolve in future. It predicts the future behavior of the dynamic systems. Just like Newton's laws tells us how the system is going to be, or what is the velocity of the system, or how the system is going to evolve. How a classical system's motion is determined by the Newton's law, while the quantum systems is determined by a Schrodinger wave equation. A wave equation in terms of a wave function predicts the probability of the events or outcome. Listen, in Newton's equation, it gives us the accurate data of how the system is going to be in future. But in Schrodinger wave equation, since it is since it governs the quantum mechanical system, and we know that there is an implicit uncertainty in every quantum system, the Schrodinger wave equation cannot predict how the system exactly will be in the next moment. But this equation, on solving the Schrodinger wave equation, it gives us an idea about how far the system, or it predicts the possibilities of how the system will behave in future. A wave equation. According to de Broglie's theory, we know that the matter waves always behaves as waves, or every matter behave as waves. According to the equation, lambda is equal to h by mv. Every mass which moves with a velocity v will definitely have a wavelength lambda. That is, we have already said, everything which moves, everything you and me which moves, has both a particle nature and a wave nature. So de Broglie actually told us the wavelength of a matter which has a mass m and a velocity v as lambda is equal to h by mv. Since we have a wave nature, definitely our situation have to be explained using a wave equation. In mathematics, we have learned that a wave equation or equation for a wave is a second order partial differential equation in time and in space. That is, if psi represents the function of a wave, then its evolution, its wave equation can be written as dou square psi by dou t square is equal to Vp square into dou squared psi by dou x squared. Here t is time, x is the direction of propagation, and Vp is the phase velocity with which the wave propagates in the direction x. So this equation is known as a wave equation, and by mathematics we know that every wave in this universe obeys this second order differential equation in time and in space. Therefore, our matter wave in this case should also obey this wave equation. This wave equation we have told is just in one dimension x. Since our wave is traveling in third dimension, 3 dimensions, we have to consider all the dimensions x, y and z. Therefore, our wave equation will become dou square psi by dou t squared is equal to the phase velocity squared into dou square psi by dou x squared plus dou square psi by dou y squared plus dou square psi by dou z squared. I can just integrate all these values into one function, that is del, and this del square is known as the Laplacian operator. I can just write dou square psi by dou t square is equal to Vp square into del square psi, where del square is equal to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. The Laplacian operator, where this is the Laplacian operator, and its value of del square is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. So let's move on. Yes, we have a wave equation, and also we know that every matter behaves as waves. So, on solving our second order differential equation, the second order differential equation that we have here has a definite solution. From mathematics, we know that this equation right here has a definite mathematical solution, and that solution is given by psi is equal to psi 0 e raised to I omega t. This equation represents a wave which is moving forward. That is, psi is equal to e raised to minus I omega t represent an oscillating wave moving forward. Because from mathematics, we know that e raised to I omega t or e raised to I theta can be written as e raised to cos omega t plus minus I sine omega t, where cos and sine actually represents a wave function. That is, we know that this is a function of cos and sine with angle omega t. Therefore, it actually represents a wave which is moving in time. I can just write dou square psi by dou t square is equal to minus omega square psi. How? Let me differentiate this psi twice with respect to time. When I do this equation, dou psi by dou t, what will I get? I will get psi 0, which is a constant. So on differentiating e raised to I omega t, what I gonna get is minus I omega into e raised to minus I omega t, because I am differentiating it with respect to time. Let me differentiate it once again. Dou square psi by dou t square, again with respect to time. What will I get? Here minus psi 0 I omega is a constant. Again I have to differentiate only e raised to minus I omega t. What will I yield? I again yield minus I omega into e raised to minus I omega t. Now, I have a minus here, I have a minus here. So, it will cancel out and become a plus. But I have an I here and I have an I here. I into I is minus 1. Therefore, here I will have a minus. Again, I have a psi 0. I have an 2 omegas here, so I will square it, omega square e raised to minus I omega t. Now look at here. Psi 0 e raised to I omega t. Psi 0 e raised to I omega t is nothing but psi. So I can replace it as minus omega square psi. Therefore, dou square psi by dou t square, as you can see here, is nothing but minus omega square psi. Again, on continuing, I can write, just rearrange it in such a way that, let me substitute this into my previous equation. My previous equation was right here. Del square psi into Vp square is equal to dou square psi by dou t square. What I have now, right now here is a value for dou square psi by dou t square. So let me substitute this in my equation right here. So what I will get is dou square psi by dou t square. On rearranging, let me write it here. Dou square psi will be equal to what I have got here divided by Vp square. So what will I yield? Del square psi is equal to dou square psi by dou t square. What I have yield is omega square psi divided by v phase velocity squared. Therefore, del square psi can be written as minus omega square divided by Vp square psi. But we know that omega is 2 pi nu, where nu is the frequency. Omega is 2 pi into the frequency. But we can write frequency nu as the velocity. The velocity here is the phase velocity divided by the lambda. Velocity of that wave divided by its wave length. Therefore, I can write omega is equal to 2 pi into Vp by lambda. On squaring, what will I get? Let me try squaring this. Omega square will yield me 4 pi square Vp square divided by lambda square. Again, right here, I have to divide omega square by p square itself. So why don't I do it right here itself? Let me divide it by Vp square. If I divide it by Vp square, what I will get? I will get omega is equal to divided by Vp square. Therefore, I can write omega square is equal to 4 pi square by lambda square. Again, I know that from de Broglie's equation, lambda is equal to h by mv, where h is the Planck's constant, m is the mass, and v is the velocity. Therefore, let me replace this lambda square by h by mv. 4 pi square. Since lambda is in the denominator, I have to invert this lambda square. Lambda square will yield me, lambda square will be equal to h square divided by m square v squared. So when I invert this, since lambda is in the denominator, what I will get is m square v square divided by h square. So the equation right here, again what I have is, this is by Vp square, omega square by Vp square can be replaced by minus, since minus is already here, 4 pi square n square v square divided by h square into psi. We have to bring in an energy term here. So, let me use the almost familiar equation, that is, the total energy E is kinetic energy plus potential energy. I know that E, my total energy E is kinetic energy plus potential energy V. Therefore, the kinetic energy can be written as E minus the potential energy V. I know that the kinetic energy is half mv square, so it can be written as E minus V. Yes, for using in this equation, I have an m here, I have a V here. Let me introduce this into here. So, to use this, I have to give an m so that a m can be multiplied here and also here. Multiply m on both sides of this equation. And also I can bring my 2 into here so that my m square v square will become, m square v square will yield me 2 in m into E minus V. Therefore, instead of writing m square v square, let me write 2m into E minus V. Therefore, minus will be here. That 2 can be multiplied with 4 and it will become 8. 8 pi square m into E minus V divided by h square into psi. Again, we know that h cross can be written as h by 2 pi. So to simplify this equation, I can write h cross square will be equal to h square plus 2 square, that will be 4 into pi square. So, what will this yield me? This will yield me this equation. How? So, right here I am going to substitute h square by 4 pi square with h cross square. So, this equation of del square psi will become minus, I have taken 4 pi square, so my 2 will remain right here, 2m into E minus V divided by h cross square into psi. I can just bring this equation to other side and make it against 0, so that my equation will become del square psi plus 2m by h cross square into e minus v psi is equal to 0. And this equation is known as the time-independent Schrodinger wave equation, because this equation we have right here is completely independent of time. Consider another case of a free particle. Case of this is when a particle is free means that its potential is 0, that it is not acted upon by any potential, it is not under the influence of any other bodies, then its potential will be 0. Such particle is known as a free particle. Therefore, in case of a free particle, this term of V will become 0 and our equation will become del square psi plus 2me by h cross square psi is equal to 0. So far we have discussed in the 3 dimension. We have explained this del as square as the Laplacian function which is in 3 dimension. Hope you remember it is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. It is second order differential in all the x, y and z directions. Let a particle be moving only in one direction, that is x. So in this case, I can replace my del square by only one equation, that is here, and the other two of z and y cancels out. So my equation will become d square psi by ds square plus 2m e minus v by h cross square psi is equal to 0. Again, in this case, if the particle is free, that is, if v is equal to 0, I will get d square psi by dx square plus 2me by h cross square psi is equal to 0. And this is Schrodinger time-independent wave equation in x direction. So, today we have learned about Schrodinger's time-independent wave equation. This is the generalized wave equation in 3D, that is del square psi plus 2m into e minus v by h cross square psi is equal to 0, where psi is the wave function of the matter wave, E is the energy of the particle, V is the potential in which it exists, m is the mass of the particle, h cross is h by 2 pi, where h is the Planck's constant, and del square is the Laplacian operator in 3-dimensional space. So dear student, in this chapter we have learned about Schrodinger's time-independent wave equation. See you in the next video. Thank you.